Okay, you've all probably heard of the terms oxidation reduction, or in other words, we call them redox reactions. What exactly are those? The term oxidation means that something lost electrons. The term reduction means that something gained electrons. So when we're looking at reactions, how are we supposed to know if something got oxidized? Well, you notice that the thing that lost electrons got oxidized. How do we know that something got reduced? It gained electrons. What's the easiest way to figure all this out? The easiest way is to assign things called oxidation numbers. Once we assign oxidation numbers, then you can immediately see when you compare the reactant to the product, the element in the reactant side and the product side, that same element, if its oxidation number went up, that means it lost electrons, so it got oxidized. If its oxidation number went down, that means it gained electrons, so it got reduced. So we'll get into all of that, but in order to do any of that, we have to learn how to assign oxidation numbers. And there are certain rules for that, and so I put them up on the board and we'll go through them together. Okay? First things first. Definition of oxidation, that is the loss of electrons or the increase in the oxidation number. Reduction is the gain of electrons or the decrease of the oxidation number of that element. Okay, now here are the rules for assigning oxidation numbers. And you've had this in an intro chem class, but hopefully this will ingrain it even better in your heads. Anytime you've got a monoatomic ion, the oxidation number is the charge on the ion. So for example, if you have, let's say, a sodium ion. Okay, well, sodium ion is +1, its oxidation number is +1. If you have, for example, an iron 3+, its oxidation number is 3+, because as an ion, I'm telling you that this is iron Roman numeral 3, its oxidation number is the charge on the ion. So that's the first rule. All monoatomic ions, their charge is the oxidation number. Okay. Number 2, all elements alone have an oxidation number of 0. What do I mean by alone? That means it's an element that's not hooked up to any other element and it's neutral. So I'm going to just erase this part so I can have some room to show you some examples. Okay, so we already talked about the first example, all monoatomic ions, their charge is their oxidation number. But what if, let's say, I had a hydrogen all by itself? Let's say hydrogen gas. Or let's say I had an iron solid all by itself. This is an element alone. It's not an ionic form. It's just a neutral element all by itself, not hooked up to anything else. Its oxidation number is 0. 0. When I had the iron ion, its oxidation number is +3 because the charge is the oxidation number. But if it's all by itself alone and no charges on it and it's not hooked up to another element, its oxidation number automatically is always 0. Okay. What's rule number 3? The sum of all oxidation numbers in a neutral compound has to equal 0. Okay, well, that goes back to some things that we've studied before. Let's say you have an NaCl. Well, I already know that sodium is a group 1A metal, and this is an ionic compound, so I know that sodium's oxidation number is for sure +1 because it's fixed charge. It's never going to change. So I have to go, what would the charge on the chloride be? It's got to be -1 so that the sum has to equal 0. Okay, so what is the oxidation number on the chloride? -1. What is the oxidation number on the sodium? +1. Okay. Rule number 4 says, and it goes hand in hand with rule number 3. Can you guys see this? Hopefully you can. Oxygen has an oxidation number usually of -2 Sometimes it has an oxidation number of -1 or minus half, depending on if it's an oxide, a superoxide or a peroxide. A superoxide is -1/2. A peroxide is -1. But most of the ones you guys are going to be seeing are just plain old oxides. Oxygen usually has an oxidation number of -2. Not when it's O2 by itself. If it's O2 by itself, it's 0. But anytime oxygen is hooked up in another compound, you're going to see it as a -2 pretty much in this class. Hydrogen is usually +1, and fluorine is always -1. So let's say I had this over here, carbon dioxide, and I want to know what is the oxidation number of the carbon. So this is a covalent compound, so you can't figure it out using ionic charges, but you can use these two rules, rules 3 and 4. You know that rule 4 says that oxygen is -2. And I have 2 of them, so that's a total of -4. I don't know the carbon, so x plus -4, according to rule 3, has to equal 0. So therefore, the carbon must be +4. Okay, that's the oxidation number. How did I figure that out? Well, +4 plus -4 would be equal to 0. Okay, manipulate the equation, solve for x. Okay, what if I had carbon monoxide instead? CO. Well, oxygen, according to rule 4, is -2, and x plus -2, according to rule 3, has to equal 0. So what would the carbon be in this situation? This would be +2. Okay? So that's what those two rules are. And then rule number 5 states that the sum of the oxidation numbers, you probably can't even see this. I am so sorry, guys. The sum of the oxidation numbers in a polyatomic ion equals the charge of the ion. Okay, what do I mean by that? Let's say I've got this substance here. I have the nitrate polyatomic ion. Okay, nitrate polyatomic ion. I want to know what is the oxidation number of the nitrogen in the nitrate polyatomic ion. Well, rule number 4 told us that oxygen is -2. So -2 times 3 is -6. So x plus -6 is going to be equal to the charge of the polyatomic ion, which is -1. So anytime you've got a polyatomic ion, you can figure out the oxidation numbers of the nonmetals in the polyatomic ion by making the sum of the oxidation numbers equal to the charge of the polyatomic ion. So we know that x has to equal +5. Okay? Good. So now that you have the rules, we can practice a few examples here. All right. Let me see what I've got here. Where did it go? Oh, here we go. All right. All right, here's one. The question is, what are the oxidation numbers of each of the elements in this ionic compound? All right, so we start off with the easy stuff. We know that potassium is, this is potassium permanganate. It's an ionic compound, metal, anion, ionic compound. So potassium, because it is a group 1A metal, it will never, ever, ever change its charge, right? Potassium is always +1. So potassium is +1. That's its oxidation number. The charge is the oxidation number. Okay. According to the rule 4, oxygen is -2. So I know that, and we're always focused on each. Yes, I know that all 4 of them together is -8, but each potassium is +1, Each oxygen is minus 2. Okay, so now the tricky one is the manganese. We have to figure out the manganese. This is a neutral compound, so that means the sum of the oxidation numbers has to equal 0, right? So we know that potassium is +1. We know that the manganese is X. We don't know what that is. And we know that the oxygen is -2. -2 times 4 is, sorry, not the equals yet. -2 times 4 is -8. All together, they have to equal 0. Okay? So I have a +1 plus X plus -8 equals 0. You manipulate the equation. Again, this is basic simple algebra. X is equal to +7. All right? That's this one. All right, so here's another one. Let's say I have the dichromate, Cr2O7, 2-. Okay, dichromate. And the question is, what is the oxidation number of the chromium, of each chromium in the dichromate polyatomic ion? Okay, so we follow the rules. Rule 4 said that oxygen is -2. So oxygen is -2, but I have 7 of them. -2 times 7 is -14. And I have 2 chromiums, so 2x plus -14. How did I get the -14? -2 times 7 is -14. Why do I have a 2x? Because I have 2 chromiums. This has to equal what? Not 0, but -2. Why -2? Because the rule said that the sum of the oxidation numbers of all the elements in a polyatomic ion has to equal the charge of the polyatomic ion. So you manipulate the equation. You get 2x is equal to, you bring this over here, it becomes +14 -2, which is 12. X is equal to +6. So each chromium is +6. Okay, what if I told you what is the oxidation number of fluorine in molecular fluorine? 0, right? 0. What if I told you what is the oxidation number of iron in this one? Well, you do the thing. This is a -2. This has to be +2. So in order to figure out the oxidation number of anything that is going to be a variable charge metal or a non-metal that you're not really sure what it could be, you're going to have to follow the rules to figure it out. Okay, last couple of ones. Let's say I had perbromic acid. This is perbromic acid. And I want to know the oxidation number of the bromine in perbromic acid. Okay, the rule is hydrogen is +1, oxygen is -2, times 4 is -8, and all of this has to equal 0, so the bromine must be +7. Well, what if I now have bromic acid? Not perbromic, bromic acid. You're going to see how the bromine is going to change. Its oxidation number is going to change. Oxygen is -2 times 3 is -6. Hydrogen is +1. What would the bromine be over here? +5. You see that? When we notice a change in oxidation number, as you're going to see in the next video, that's when we notice that electrons have been gained or lost. Anytime an oxidation number of an element goes up, it got oxidized. If the oxidation number of the element goes down, that element got reduced. Okay, so we'll talk about some redox reactions and different types of reactions that can be redox in the next video.